Hello everyone and welcome to our next installment of video game programming with Unity. Today we're going to dive into uncharted territory for us. Up until now all of our projects have been in 3 dimensions, and today we are going to flatten out our perspective and work on our first 2D game. So I'm showing you my view from the project creation window because there's actually some default settings that Unity will set up for us if we choose to make a 2-dimensional project. So I'm going to make a new project, and I'm going to call this project 2D game. And notice that 3D by default is checked in here. I'm going to change that to 2D. And this will set some things in motion that will allow me to get my Unity project up and running without having to manually set up some things myself. So we're going to wait for this to load. And when we get in here, the first thing you're going to notice is that our camera is very, very different. So right here, if we look at our camera space, we can see that the camera appears to be a flat grid. We're not looking at a skybox. We're not looking from a different angle. We're just looking at this flat grid with a camera. This camera, I'm going to select it here, is what is called an orthographic camera. So see right here that the projection is set to orthographic. By default, in a 2-dimensional project, we want a orthographic camera so that our perspective is always flat. What an orthographic camera does, and let me bring over my notes here. So an orthographic camera has no depth, meaning that the z values for my objects do not matter. The x and y values are the only things that are important here. And the reason for that is that I want to, in a 2-dimensional game, I want to express depth by changing the sizes of my objects and my 2-dimensional sprites. I don't want to be representing depth in a 3-dimensional way in a 2D game. So instead of using 3D placement to represent depth, we're going to use something called a sorting layer, and we're going to change the sizes of objects to give the appearance of depth. It's like how we would traditionally draw things smaller to make them look farther away. So let's talk about adding stuff to our game. When we add things to images to our game that represent 2-dimensional characters or players or whatever, we are creating what is called a sprite. So I think I may have used the vocabulary sprite before in this class, but traditionally when we say sprite, we're talking about 2 dimensions. We're talking about flat images that make up characters. We can also use sprites to refer to things in the environment or background tiles, things of that nature. So I'm going to show you a couple of different ways to get sprites into our game, and then we'll talk about how we're going to use sprites in the future and some of the different options we have for game objects in 2 dimensions. So I'm going to do some built-in Unity stuff first, and then I'm going to show you guys how to add sprites of our own. So we've made our 2D project. I am going to add a new sprite by going to my game object, and I'm going to go down to 2D objects and simply add a sprite, new sprite. And I'm going to call this character. So this sprite exists, but it is not actually taking up space right now. If we look at what belongs to this character, we have a transform, which we always have, and then we have a sprite renderer. And notice that the sprite right now is set to none. So we need to actually get a sprite into our game. So I'm going to go ahead and import something that's already in Unity. I'm going to go to Assets. I'm going to go to Import Package, and I'm going to import 2D. Now, don't panic. I know that some of you guys have had issues before with the asset store not showing up. I mean, not the asset store, the built-in assets not showing up. What I'm about to show you, we do not have to do through Unity. We can always go and get stuff from the asset store. We can download our own sprites, which I'm going to show you guys in a second. So while this imports, what I'm going to be doing is taking a single individual sprite and placing it on my sprite renderer. So that way we'll actually see our character in the scene. So I'm going to go in the standard assets folder. Maybe. I am going to go under 2D, sprites, And we are going to choose, let's see, what do we have? We got a bunch of robot boy sprites. So I'm going to grab this robot boy sprite, and in my character section, I'm going to drag this into the sprite area. So now we see that my robot sprite appears on the screen. Now you may notice that this actual sprite here, the actual image, contains a bunch of different robot images. This is using something called the Sprite Sheet, which is how we animate in 2D, but we're going to talk more about Sprite Sheets in the next section. For today, we're not going to worry about any animation. So here is our character. Here's a little robot, and if I press play, we should see our robot on a blue background. So we've imported our first sprite that's already built into Unity. But what do we do if we want to add other sprites that we make ourselves or sprites that we pull down from the internet? Well, what I'm going to do is I'm going to import a sprite that I've pulled down from the internet, and then I'm also going to show you guys how we can add certain components to our sprites and how we can organize them using layers. So I'm going to go onto my desktop. Let's say that we want to build a game that uses everybody's favorite Nintendo character, Iggy. So here's Iggy, the Koopa Kid. We want to add him to our game. Now, obviously, Iggy is not included in the standard assets for Unity, so we're going to have to bring him in ourselves. So I'm going to drag Iggy off screen for a moment so that I can put him into the Unity game. Open up Unity, and I'm going to go back to my Assets folder. I am going to create a folder called Sprites. Remember, it's always a good idea to organize with folders, and I'm going to drag Iggy into the Sprites folder. Now, because this is a 2D game, notice that when I inspect the Iggy image, by default, it is set up as a 2D sprite. See where it says texture type here? Sprite 2D. We want to make sure this is the case. If we were in a 3D game, we would have to set this ourselves because it would be coming in as a default rather than a 2D sprite. But now that we've got him imported as a sprite, dragging him into the scene is actually really simple. All I have to do is pull Iggy up here, and now I have my sprite. So there's Iggy, here is my robot, and they coexist in our scene. Now notice right now that because I added Iggy later, Iggy appears in front of my robot sprite. And let's say that we wanted to not only make this make Iggy appear behind the robot sprite, but let's also say, I'm going to change this because this is ugly. Call this Iggy. Let's say we also wanted to make them bigger. We want them to take up more space in the camera. In a three-dimensional game, we would move the camera closer to our objects. However, we don't have that luxury in a two-dimensional game because an orthographic camera makes everything the same size. It keeps everything, all the perspectives, same. So then how are we going to make it so that our orthographic camera sees them in a different size? What we're going to do is we're actually going to change the size of the camera itself. And by changing the size of the camera, we're going to change the viewing area and also change how big everything in the camera is. So if I bump up the size to, I want to go the other way. Bump up the size to 2. By making a smaller sized camera, I've reduced the amount of space that the camera can see. So now, if I play the game, my objects appear much larger in my camera. Now, one other thing I want to point out when it comes to sprites, notice that the sprite mode for Iggy is single. We have another option here called multiple. We're going to get to that later when we start dealing with sprite sheets. But Iggy himself is not going to be able to be a sprite sheet because he only has a single image. If we go back to our robot, notice that the sprite mode for the robot is multiple. And if I expand the robot, I have all these different parts of an animation for the robot. We're going to learn how to do that more in the next class. But for right now, if we're importing a single image, then we want our sprite to have the type single and not multiple. So just keep an eye on that for the work that you guys do in class. Okay, so we've added our sprites, we've put them in the game. Now we're going to learn how to affect our drawing order, or how to organize it so that the robot appears in front of Iggy. This becomes especially important when we start adding backgrounds and scenery. We want to make sure that everything appears in the proper layer or in the proper order. So what we're going to do is we're going to organize things by sorting layer. So to organize things by sorting layer, we need to have some layers first. So I'm going to click on my sprite here, and you see where it says sorting layer default. All of my sprites are on the same layer at the beginning of the game, which is fine, except that that means that my sprites are going to appear on top of each other based on who was drawn or added last. Because Iggy was added later, he is drawn on top of my robot. So what I'm going to do is I'm going to add a sorting layer here, and I'm going to call it player. And then I'm going to click on, this is kind of like when we did tags before, I'm going to click on the robot and I'm going to change this layer to player. And I'm also going to select Iggy. I'm going to add a new sorting layer, and I'm going to call this layer bad guy. And then I'm going to select Iggy, and I'm going to change his sorting layer to bad guy. So now we have the robot on one sorting layer, and we have Iggy on another sorting layer. And we're going to see how they show up now. So notice that when we edit the sorting layers, they appear in a different order. So if I go to back to my layers here, actually I'm going to do it through a different menu. I'm going to go to Edit, then I'm going to go to Project Settings. I'm going to go to Tags and Layers. So we see here that we have layers in a specific order. There's the default layer, then the player layer, then the bad guy layer. I'm going to drag the bad guy layer above the player layer. And now, notice that Iggy does not appear in front of the robot anymore. He appears behind the robot. And again, just so you guys see where I went to Edit, and then I went to Project Settings, Tags and Layers, and reorganized my layers in this way. This is a really great way to organize foreground, so things that are in front of the characters themselves, and background layers. And then sometimes we may even have backgrounds that are further off that we want to put into even farther back layers. In general, if we can avoid it, we don't want to use the default sorting layer. We should always make our own layers so that we know exactly what order things are going in, because our default layer, see how it's grayed out? It's kind of like our fallback. If everything were on the same layer and we didn't need any of our own layers, then we could use the default. But as soon as we start putting in backgrounds and foregrounds and all that stuff, it's a good idea to have multiple layers that we create specifically. Okay, so let's talk about one more piece. Now that we have these sprites, remember that these guys are just game objects. They are no different than any of the other game objects we've run, except that they are flat in 2 dimensions, meaning that we can script them in exactly the same way that we would script anything else. It's just that we don't have z values. We wouldn't, for example, if we wanted Iggy to move, we would move Iggy in the X and Y direction. We wouldn't bother to move Iggy in the Z direction because Z doesn't matter. In an orthographic perspective, the Z is flat. It's all the same. So scripting, nothing changes. Everything we've learned so far can be applied. The only thing that does change is that we need to make sure we're using certain physics components. So if I were to go add a rigid body to Iggy, notice that rigid body has 2 versions. There's the regular version and there's the 2D version. Some of our physics components, such as rigid bodies and colliders, have 2D versions of the component. We always need to make sure that we use the 2D versions of components when possible. The reason for this is that if we were to mix 3D and 2D objects in a game, 3D components will not interact with 2D components, meaning that a 3D rigid body will not collide with a 2D rigid body. And I'm going to also add a rigid body to my robot. So we have rigid bodies for these guys now, meaning that they fall. We see that gravity there. They don't have colliders at the moment, but let's see what happens if we do add a collider. So I'm going to put our robot up here above Iggy, and I'm going to not have Iggy be a rigid body. Instead, I'm going to give Iggy a box collider, but I'm going to do the 2D version. So now Iggy has a box collider around him. So the robot is a rigid body, so it has mass, it falls. I've also added a collider to the robot, and I have given Iggy a collider so that he stays in place. He's not a rigid body, but he does allow collisions. He does allow the rigid body of the robot to hit him. So now if I hit play, the robot's going to fall a little bit because he's a rigid body, he has gravity, but he's going to stop when he touches Iggy's box collider. So you can see that all that physics stuff that we did before is exactly the same, except that now it's only worrying about 2D versions of the objects instead of 3D versions. So hopefully that gives you guys some insight on how to do 2D objects. We're going to do some scripting tomorrow so that you guys can practice writing scripts for 2D objects. But remember, don't be intimidated by the code. The code that you've been writing for 3D objects is going to be exactly the same for 2D, except that the movement won't worry about the Z direction. We'll only be worrying about the X and Y directions. Thanks for watching.